Salts, as you all have already read, that salts are formed by the combination of an acid and a base. Therefore, a salt it consists of a positive cation of a base and a negative anion of a acid. Now, the salts they are usually considered to have a pH 7, which is the neutral pH, but the salts of a strong acid and a weak base they have a slightly acidic pH, while the salts of a strong base and a weak acid will have a basic pH, while the salts which are the combination of a strong acid and a strong base they have a neutral pH. Now we come to the properties of salts. Salts are ionic in nature due to the presence of ions. They are brittle, hard, and crystalline solids. Salt is usually odorless and has a salty taste. Now we come to the salt which is most commonly used in our kitchen, which is the common salt, which has a chemical formula NaCl, that is sodium chloride. Common salt it has a raw material for various other salts like sodium hydroxide, baking soda, washing soda, and bleaching powder. We'll study a bit detail of these in the next slides. Brine solution is an aqueous solution of sodium chloride which decomposes to give chlorine, hydrogen, and sodium hydroxide upon the passage of electricity. This whole process is termed as the chlor-alkali process, which has been discussed in the next slide. Now we come to the preparation of sodium hydroxide from the brine solution. This process is also termed as chlor-alkali process, wherein chlor stands for protein and alkali is the sodium hydroxide. In this process, electricity is passed through the aqueous solution of sodium chloride, and upon the passage of electricity, this solution decomposes and there's a formation of sodium hydroxide which is in the aqueous form. Chlorine is released in the gaseous form from the anode, and hydrogen is also released in gaseous form from the cathode. Now the three products which are released are all useful in their own ways, the uses of which have been discussed in the next slide. Now we come to the uses of sodium hydroxide or the caustic soda. As we had studied in the previous slide that there were three products which were released after the electrolysis of the sodium chloride solution: the hydrogen, the chlorine, and NaOH. Now the hydrogen which is released, it is used in the fuels, in the margarine, it is used as ammonia for the fertilizers. The chlorine which is released at the anode, it is used in water treatment, in the swimming pools, it is used in the PVCs, in disinfectants, in CFCs, that is the chlorofluorocarbons, and it is also used in the pesticides. Now the NaOH solution which is released, it is used in the degreasing of metals, soaps, and detergents. It is also used in paper making and is also used in the artificial fibers. Now bleaching powder. Bleaching powder has a chemical formula CaOCl2, that is calcium hypochlorite. It is formed by the electrolysis of aqueous sodium chloride, which is also known as the brine solution, which releases chlorine gas. This bleaching powder is formed by the reaction of slaked lime, that is calcium hydroxide, plus chlorine gas which is released from NaCl. This gives rise to CaOCl2, that is our bleaching powder, plus water. Now the uses of bleaching powder. This bleaching powder is used in the textile industry for bleaching cotton and linen. It is also used for bleaching wood pulp in paper factories and for bleaching washed clothes in laundry. It is also used as an oxidizing agent in chemical industry. It is also used in disinfecting drinking water so that it becomes free of germs. Baking soda. Baking soda has a chemical formula NaHCO3. It is formed by sodium chloride, that is, sodium chloride is acting as a raw material. Sodium chloride, upon reaction with ammonia and carbon dioxide and water, gives rise to sodium hydrogen carbonate plus NH4Cl, that is ammonium chloride. The sodium hydrogen carbonate in this reaction is the baking soda. Now, baking soda is a commonly used name in the kitchens. It is used for making baking powder, which is used in the cooking. The carbon dioxide, which is released by the baking soda, it makes the bread or the cakes rise and hence makes them soft and spongy. It is also used in antacids. Antacids are used to curb the effects of acids in our stomach, or it is used to treat acidity in the stomach. It is also used in soda fire extinguishers. Washing soda. Washing soda is yet another chemical which is obtained from sodium chloride. It has a chemical formula Na2CO3.10H2O. Now, the reaction to obtain washing soda is as follows. It is Na2CO3, that is sodium carbonate, plus water will give Na2CO3.10H2O. Now, the 10H2O means that it is the water of crystallization, which we will study about when we come to the copper sulfate topic. Now, we come to the uses of washing soda. Now, how is washing soda useful? Sodium carbonate or washing soda, it is used in the glass, soap and paper industry for various purposes. It is also used in the manufacture of some sodium salts such as borax. This sodium carbonate or washing soda is used as a cleaning agent for the domestic purposes. It is also used for removing the permanent hardness of water. Copper sulfate. Copper sulfate are the blue colored crystals which are usually found in a chemistry laboratory. Copper sulfate has a chemical formula CuSO4.5H2O. It is usually blue in color, as you can see in the picture, and it is also known as blue vitriol. Now, we'll perform an activity to show that the copper sulfate crystals, they contain the water of crystallization. For this, we require blue crystals of copper sulfate, a dry test tube and a flame. Now, we'll heat the copper sulfate crystals in a dry test tube for some time. After some time, when we remove the test tube from the flame, it is observed that the blue copper sulfate crystals change into copper sulfate powder, which is white in color, and the water vapor gets condensed in the test tube. Now, why these copper sulfate crystals have changed into white color? This is because the blue color of the copper sulfate crystals was due to the water of crystallization present in it, and upon heating, this water of crystallization evaporates and the copper sulfate crystals, they change into white powder. It is shown by the reaction which is given here, that is blue crystals of copper sulfate, that is CuSO4.5H2O, upon heating will give anhydrous copper sulfate plus 5 molecules of water. Now, if we again add water to the anhydrous copper sulfate, it will again change into blue color. This shows that copper sulfate crystals, they contain water of crystallization, which imparts a blue color to them. Now we have come to the last topic, which is plaster of Paris. Plaster of Paris has a chemical formula of CaSO4.5H2O, which is calcium sulfate hemihydrate. It is commonly known as plaster of Paris. Now, if plaster of Paris is combined with water, it gives gypsum, that is calcium sulfate 2H2O. Now, the plaster of Paris, it has certain uses. Plaster of Paris is used for fixing the bones. It is used for supporting the fractured bones. It is used in making toys, in the materials of decoration. It is used in making the surfaces smooth. Plus, it is used in many other things. The plaster of Paris is most commonly used in the construction purposes, in the medical purposes, for decoration purposes, and so on.